All right, had some technical difficulties. Had to restart the whole thing with this video. So we're gonna blow this up just a little bit. It says triangle ABC with these points is rotated 90 degrees counterclockwise about the origin. What are the coordinates of the vertices of the figure after the triangle is rotated? All right, so I'm not gonna make a mistake like I did in the last time I rotated clockwise and I had to redo the whole thing. But y'all don't know that because that's the wonders of technology. All right, so 90-degree counterclockwise means that we go from XY and you go counterclockwise, and you're going to say, hey, we're going to put that Y in the front, change the sign, and put that X in the back. That's what it means. All right, so my pen tool needs to lose a little weight because it's a little thick around here, a little thick, and we just need a little, because I blew it up and now it's not going to be enough room for me to write these coordinates down. All right, so let's put in the coordinates the way we're doing it. Let's make sure we do this right. All right, so this says, hey, bring U to the front and change the sign. I think we're a little too thin. All right, look at that gold. All right, bring U to the front. So bring 1 to the front, change the sign, and take I changed the sign on both. And take U to the back. That's what A prime means. I'm gonna gain a little weight, just a little weight. All right, and then B prime says, hey, take Y to the front and change the sign. So Y to the front, change the sign, and bounce X to the back. That's what it means, y'all. All right, you're saying, hey, bring Y to the front, change the sign, bounce X to the back. And now we have our ordered pairs. And so we're going to do this because we know we go counterclockwise. Some of y'all can see it. I can't. I'm just letting y'all know right now. I always need to use the notation. All right. -4. A is -4, -1. -4, -1 is right here. A. And B is -2, -1. B. We might have another skinny triangle. And then C is -4, -1, 2, 3, 4, 4, 1, 2, 3, 4. Y'all don't make a mistake and say that's 1. That's 0. This is 1, 2, 3, 4. All right, this is C. Now, let me tell you why I need to use notation. I don't know what in the world. This is supposedly is going to rotate like this way, counterclockwise. I don't know what that looks like. I'm gonna be honest with you. I'm just spatial reasoning. I don't. It's not my gift. All right. So technically, A is going to rotate out of quadrant 3 to quadrant 4. B is going to rotate out of quadrant 3 to quadrant 4, and then C is going to rotate out of quadrant 2 to quadrant 3 because 90 degrees goes to the next quadrant. All right, I'm gonna change the color to my favorite color, which is lava. All right, so 1, -4 for A prime. 1, -4. 1, 2, 3, 4. A prime. Y'all, I'm on the wrong. That's -1, -4. I was about to say it didn't rotate out this quadrant. 1, -4. 1, 2, 3, 4. That's how I knew I was doing something wrong. See, when you know what's supposed to happen, you can correct your mistakes. A prime. There you go. 1, -2. 1, -1, 2. B prime. You're supposed to be over here. B prime. There you are. And then -4, -4. You're supposed to be from this quadrant to this quadrant. -4, -4. -1, 2, 3, 4. 1, 2, 3, 4. C prime. Now I would never got this right without this notation. I'm just being honest. This would not be the triangle I drew. That's why it's good to know it. Some of y'all would have did that. It's good for you. All right, this is a counterclockwise rotation around the origin. Let's keep it moving. All right, a line segment with endpoints -6, 2 and n -4, 8 is translated 6 units to the right and 2 units down. What are the coordinates of the endpoints after the transformation is performed? So I am going to graph them and then just move them visually. That's what the graph is there. If you want to use the notation of adding 6 and subtracting 2, it'll be the same thing as well. All right, so -6, -2, so M is -6, -2. 1, 2, 3, 4, 5, 6. 1, 2, -6, That's negative 6, negative 2, Mr. O'Neill. Negative 6, positive 1, 2. That's M. And then negative 4, 8. Negative 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8 is N, right? And it's a line segment. These are the endpoints. So that's that. And then we're saying, hey, buddy, we want you to move 6 units to the right and 2 units down. Let's pick a new color. Let's go back to that gold, because some gray is going to be golden. Living my life like it's golden. Living my great life is golden. All right, so 6 units to the right. 1, 2, 3, 4, 5, 6, and 2 units down. 1, 2 is N prime. There you are. 6 to the right. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 2 units down. 1, 2. Well, will you look here? You're at the origin. M prime. So what are my new coordinates? Well, M prime, that's easy. That's 0, 0. Why? Because you added 6, subtract 2. That's 0, 0. And then N prime is going to be 2, 1, 2, 3, 4, 5, 6. 2, 6. Added 6. Subtract 2. That's what it be. That's what it be. All right. Triangle XYZ with vertices, blah, 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 are translated so that X prime is 2, 2. What are Y prime and Z prime? Okay, for the sake of time, we're not going to graph this. We're just going to use you would graph it in the future, but this video is going to be super long if I graph everything. So yeah, y'all graph them on your own. I will be checking to make sure you graphed on your own. Oh, you gotta get with these people. You don't do it. I'm like, you ain't doing it in the video. I said graph it on your own. So if X prime becomes 2, 2, how does 4, and translating means to slide, that means add and subtract. This means to add or subtract. Okay, so 4 becomes 2 by subtracting 2. So my notation means that I'm going to take 2 away from 4, from every X. 5 becomes 2 by subtracting 3. So I'm taking 3 away from every Y. So I'm subtracting 2 from my X's, subtracting 3 from my Y's. Like, why is it hard? It's not. You know what I'm saying? Even if you graphed it and graphed 2, 2, then you would look at the image. Say, I'm just going to graph the first image so y'all can see. So 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. That's X. All right, 4, 5. And then X prime becomes 2, 2. 2, 2. What did I do? I went 1, 2, 1, 2, 3. That's what I did. I went left 2, down 3. What does this mean? Left 2, down 3. So, I mean, you could graph them and get the order pairs, but just for the sake of time, I'm not. All right, so Y prime. I take, what am I doing? Take 2 away from 7, I'm left with 5. Take 3 away from 8, I'm left with 5. All right, Z prime. I take 2 away from 5, I'm left with 3. Take 3 away from 1, I'm left with negative 2. Y'all gonna graph that. Yep, do that with your life. Yep, that's what you can do with your life. Yep, that's what you can do with your life. Yep. All right, number 8, rectangle. Let me shrink this so we can see the whole thing. Rectangle WXYZ will be dilated by a scale factor of 2. Rectangle W prime, all that. That's what we get. What will be the perimeter of rectangle W prime? What if the perimeter is dilated by a scale factor of 1/2? What will be the perimeter of? Yep. All right. So we know that this image right here will be dilated by a scale factor of 2. So if this is the image, so I have 1, 2, 3, 4. This is 4. Look at that go. 1, 2, 3, 4 by 2 by 4 by 2. Well, 4 plus 2 is 8. What am I talking about? It's 6. 4 plus 2 is 6. And then plus 4 is 10. Plus 2 is 12. So the perimeter of this is 12. They don't give us any units. So 12 units. So if I dilate, the scale factor of 2 means to multiply. Yes, write it. Multiply. So 12 times 2 gives me a perimeter of 24 units. It's not squared because this is perimeter. Now, you could draw it. It could help you out, whatever. I'm not going to draw it because I understand the math. All right, and then that means every point is going to grow by 2. That's what that means. And then what if it's scale factor of 1/2? This means to multiply each coordinate. All right, so if we do that, we end up, now this becomes 4, 2, 4, 2. That's what it is. And so we have 12, and 12 times 1/2, which means take half of it or divide by 2, is 6 units. That would be the perimeter of the new image. All right. How much more do we have? Ooh, gosh. This is becoming long, ain't it, y'all? Oh, well, so that you get a good grade. Nobody cares. If line segment BC with these other coordinates is translated to be that B prime is located at 2, 6, what will be the coordinates of C prime after the same translation? Y'all, this is what we just did. Just another practice. If you see it here, you're more than likely going to see it on your test. So B was 3, -3, 8. And then it went to B prime of 2, 6. So how does -3 become 2? I mean, mathematically, you can do 2 minus -3 to see what you got. You can work backwards. But that means 2 minus -3 is 5. So we went from xy to x plus 5. I always do that. Well, we're not closing that. It's a comma. And then y, how does 8 become 6? Well, we do what? 6 minus 8 is -2. You subtract 2. All right. Okay. All right. So what do we need to do? We need to, for C prime, C is 2, -2. Therefore, C prime, we add 5 to that. That's 7. And we subtract 2 from that. That's -4. Use your calculators, y'all. If you think you're going to get that wrong, get your life together. All right, describe the sequence of transformations that results in the transformation of figure A, smaller, to figure A prime, which is larger. So this is the image. This is the pre-image. So what is happening? Okay, we see, are they the same size? It's a dilation, so but we're not going to do that first. So what we did first, we turned this. And we rotate it. What? We rotate it from one quadrant to the next. So there's a 90-degree clockwise rotation. Look at that go. All right. And then after we rotate it, look here. What do? Everything got larger. By what? Well, this is a 1 by 1. This is a 2 by 2. And so it's a scale factor. We should probably call it a dilation because some of y'all gonna put scale factor and be wrong. So I'm gonna do this 90-degree rotation and with a dilation of a scale factor of dose. That's what we did, people. All right. So what about this one? Well, this one clearly is a flip, right? So we went from smaller to larger. I was just about to make a mistake. Smaller to larger. So we flipped. A flip is a what? Reflection. Where do we reflect over? Over the what? Y-axis. And when I reflect over the y-axis, I ended up here. And what do we also do? We translate it. Okay. And for your test, you don't have to be specific. Just tell me the direction. Left and up. And then what's the last thing we did? Y'all, we went from a side of 2 to a side of 3. It's new over old. New, the new side is 3. The old side is 2. So then it's a dilation of what? New. 3 halves. All right, that's that. It doesn't make sense. Go back and rewind and watch it again. What's the scale factor? New over old, new over old, new over old, new over old. Goodness gracious, I'm about done, y'all. If y'all feel this, I'm about done. 1, 2. Prime means it's new. Image, pre-image. New over old, which is 1, 2, 3, 4. Any points, y'all. Therefore, scale factor is 1/2. We know that it's going from large to small. All right? Okay? All right? Is that 4? That ain't 4. That's 6. Look at Mr. O'Neil. About to make a mistake. This is 2 to 6. It says it real big. Ain't no 1/2. It's not 4, y'all. All right. 4 more. 2 plus 4 is 6, Mr. O'Neil. 1/3. I can hear Pablo now. Watch him say 2 plus 4 is 6, Mr. O'Neil. Aggravating life. All right. So figure A is the pre-image. That means it's 4 before. And B is the image. So you went from big to small. Same thing over here. Big to small. All right. So you can pick any one. I'm going to pick you because I just like you. Big to small. So big, 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 big. Big is at 1, 2, 3. It went from big to small. All right. So the small image is the new. New over old. New, y'all. New is 1. Old is 1, 2, 3. Both of these is the scale factor of 1/3. All right. All right. This is the end. Woo, gosh. It's about to be over. All right. Triangle A, -2, 2, blah, 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 is rotated 180 degrees about the origin. We know that this now becomes -x, -y, but we know it's not -x, -y. That's not the way we understand. We can read it like that, but it says take the opposite sign of both. So this is going to be pretty simple, y'all. Take the opposite sign, 2, -2. Look at this go. Take the opposite sign. I skipped that one in my head. 2, -6. Do the opposite sign of both. Do the opposite sign of both. Gosh, we're almost there. 90 degrees clockwise. I know that clockwise say move you here. So I know I'm going that, well, it's always good if I write both of these out. X, Y, move you here. So now I end up with Y, opposite sign of X. So move you, change the sign. All right, move you there. So this says put the Y in the front. Change the sign of the X, put it to the back. Put the Y in the front. Change the sign of the X and put it to the back. Put the Y in the front. Change the sign of the X and put it to the back. Yay! Counterclockwise. So, X, Y. Yes, I want you to write this. I'm not playing with y'all. Now becomes -YX, which is red, opposite sign of YX. So this says put the Y in the front. I had to think, y'all. It's getting late. Put the Y in the front and change the sign. And put the X in the back. Put the Y in the front. Change the sign. Put the X in the back. This sounds like I'm black and I'm proud. Put the Y in the front. Say it loud. Oh, gosh. I am. You know, Black History Month was just a couple of days ago. And, you know, February 28th is the shortest month. So it's it's March 3rd. So I'm still celebrating because if I had 31 days, if we had 31 days, I don't care. I'm still celebrating. So put the Y in the front and change the sign. Put the X in the back. Say it loud. All right, so I'm done in this video. Hope you found humor and laughter, and hopefully I did these right. If I didn't, oh well, you can call me out when I get back to school. All right, have a great life. Miss y'all. I know y'all miss me. Bye.